Today we're discussing fish facts, hazard identification, and exposure assessment of methylmercury in fish consumption with Dr. Henry Anderson, Chief Medical Officer for Environmental and Occupational Health, Wisconsin Division of Public Health. What is hazard identification and why is it important for health professionals to understand?
Everyday health professionals do hazard identification when they deal with medications. But in this instance, there are two components to hazard identification. First is determining what adverse effects can be caused by a toxin, at what dose, and who is most vulnerable. In other words, the science behind the advice. Methylmercury is a neurotoxin. The fetus and children are particularly vulnerable to health effects from exposure because of their developing neurological system. Second is understanding how people are exposed to the toxin so it can be avoided. In the case of methylmercury, nearly all the exposure comes from eating fish, both commercial and sport caught. It's important for health professionals to understand the science behind the guidance they provide to families who are interested in learning how to reduce risks through safer choices of fish that they consume.
What do we currently know about methylmercury concentrations in different species of fish?
Levels of methylmercury can vary by region as well as water body. Specific local information can be obtained from state and local health and environmental agencies. However, a good general rule of thumb is that fish that eat other fish grow to large sizes and live a long time, accumulate the most methylmercury, as well as other environmental toxins. So, for example, swordfish, shark, some types of tuna like big eye or ahi are the highest in methylmercury, as are sport-caught freshwater fish, such as large northern pike, walleye, and bass. On the other side, we also know that smaller, younger fish that don't consume other fish are lower in methylmercury. These include anchovies, sardines, and shellfish such as shrimp and clams, and sport-caught fish such as panfish. It's important to avoid some fish altogether, particularly for pregnant women and children, because of the risk of neurodevelopmental issues that might arise.
Are there other factors that can impact risk for families that eat fish?
Health professionals need to remember in talking with your patients, you are trying to estimate the dose of a toxin. Portion size and frequency of consumption can all impact dose received and the risk of adverse effects. A typical restaurant fish portion is about 4 to 6 ounces and the size of the palm of your hand. However, when people eat out at all-you-can-eat fish fries or buffets, they may be eating more than one serving of fish in one setting. After a successful day of fishing, anglers often consume larger portions as well. So asking about meals of fish a week is not sufficient to estimate dose. Although they may be eating fish lower in methylmercury, such as haddock, consumption of large portions of fish will increase the dose and risk. The frequency of fish consumed is also important to consider. Even eating a low mercury fish every day, such as bluegill, will increase your risk for toxicity because the methylmercury bioaccumulates and slowly excreted.
What is exposure assessment and why is it important for health professionals to understand?
Exposure assessment is really putting it all together, estimating the magnitude, frequency, duration of exposure, and individual vulnerabilities to a toxin like methylmercury. It is important for health professionals to understand that some groups of people are more at risk for methylmercury toxicity based on their vulnerability to this toxin. For example, because methylmercury is a neurotoxin, children are particularly vulnerable to health effects from exposure because of their developing neurological system. For example, a 45-pound child that eats 1 can of albacore tuna per week will be 3.6 times above recommended levels set by the US EPA. To stay within EPA guidelines, tuna intake cannot exceed 1 can per month. Other populations with high fish consumption and therefore exposure, such as island and coastal populations, or those eating fish for a heart-healthy diet, can have methylmercury exposures substantially higher than those reported in national surveys. Recently in Wisconsin, we surveyed residents about fish intake and measured methylmercury levels through hair sampling. and found that men were significantly more likely to have higher levels of methylmercury than women. In addition, average hair mercury levels were significantly correlated with monthly fish consumption estimates. In other words, the more fish eaten, the higher the levels of methylmercury in hair.
Is hair sampling the only method used to measure exposure to methylmercury?
Monitoring for methylmercury exposure can be accomplished through the measurement of the total mercury content of blood, whole blood, hair, or toenails. Hair measurements are less invasive and can estimate exposure over several months, helping to establish the timing of exposure to methylmercury. Methylmercury in the mother's blood is correlated with exposure to the fetus and represents shorter-term exposure. There are online tools that can calculate a person's approximate blood or hair concentrations and thus health risk, based on the weight of the individual and fish consumption habits, including type of fish, frequency of consumption, and portion size. For those interested in more information on exposure assessment, Module number 3 will describe clinical assessment and management in more detail.